Hey everyone, welcome to another episode of Ruby Rogues. I'm David Kimura, and today on our panel we have John Epperson.
Hello, everybody.
Luke Stutters.
Hi.
And Matt Smith.
Hey there.
And today we are introducing a special guest, James Dabbs.
Hey, y'all.
And so, James, would you please give us a bit about who you are, some of the things that you're working on, who you work for, and all that good stuff?
Yeah, definitely. So I work at Procore Technologies. We're kind of based in Carpinteria near Santa Barbara. Kind of been here for 2 years. I work in the platform group, kind of specifically with the permissions team. So we've got like a pretty big long-standing Rails monolith and are working on kind of like how do we have a solid foundation for platform and permissions specifically, and kind of break that monolith apart. Kind of, many of the problems that you touch on with a large legacy Rails app. I get like background-wise, in a former life, I was an academic mathematician. The plan was to be a professor. Kind of fell off the rails there somewhere. But I think a lot of that background like informs the things that I'm interested in and the way I think about stuff. Kind of like a motivating idea behind some of the talks that I've given in the past.
Hey folks, this is Charles Max Wood, and I just launched my book, The Max Coder's Guide to Finding Your Dream Developer Job. It's up on Amazon. We self-published it. I would love your support. If you want to go check it out, you can find it there. The Max Coder's Guide to Finding Your Dream Developer Job. Have a good one. Max out.
And so you did a talk at RailsConf a couple of years ago, or I guess it was last year, on refactoring live primitive obsessions. Could you give us a high-level overview of what that talk was about?
Totally, yeah. So that was an outgrowth of a couple things. One, like I said, I work at Procore. We've got a really cool kind of internal program there where we work on refactoring, kind of hands-on. That is an outgrowth of my background as a teacher. Back in grad school, I took a lot of classes that were taught more method style. Have you all heard of that concept ever? I think that's mostly an academic math thing. The idea with
style, sorry?
Moore method.
No, never heard of it.
So the idea with the Moore method is kind of any math class you ever take is about the same. Like you have a textbook, it's got definitions and theorems and proofs and new definitions and on, right? So the idea with a Moore method class is you take a textbook, you delete the proofs, you hand it to your students and you go here, you fill these in. I'll be here if you get stuck.
That sounds like a nightmare.
It's hard. It forces more engagement than any other class that I ever took. But I realized on reflection that I learned so much more from them. The hands-on actual practice of doing the thing is really important to searing in the knowledge. And that was kind of I found that as I left academia, I saw the same thing pop up a lot. I'd go to a lot of meetup groups where we'd look at some new gem and we'd read the README of it, and I would forget it by the next week, right? The things that made it stick was the actual practice, right? So forever ago, back when I lived in Atlanta, I started an intermediate Ruby group that was kind of targeted at let's take one of these and really dig into it and practice with it and put it through its paces. Kind of similarly, when I got to Procore, we started a group where we tried to kind of put the practice of refactoring into action, right? If you've watched my talk, I don't think I present any big new ideas that you haven't heard if you've seen Sandy Metz's Nothing is Something, right? These are, I think, well understood ideas that we talk about a decent amount, but the process of putting them into action is still hard, right? If you have a big Rails application where the tests take 30 seconds to boot up, where the dependencies spiral everywhere, actually doing that, where releasing it requires coordination across a whole bunch of teams and gems, the practice is hard. And so that group existed as a space for us to kind of get that practice.
It's a great talk. I mean, I learned how to use the spaceship operator properly. That's what I learned from that. I'd never seen it used in anger, and you used it. It made sense. Great talk.
I think that's one of my other big nits that I wanted to pick with that talk is, so much of the material that's out there is this very esoteric gem, and we see relatively little of those sorts of incidental small choices that you make along the way of developing something. And I want to see more content like that. It's just the day in, day out, what's in the standard library that I can use? What are these little small tips and tricks? The spaceship operator isn't an advanced enough thing or an interesting enough thing to have a 30-minute talk on, right? So I wonder how can we get knowledge of those sorts of things circulating more broadly? And I think pair programming, these sorts of workshop groups and talks where there are more live coding are the solutions that I'm kind of stumbling towards.
One thing I didn't like was your editor combines the less than and equal to characters, and no one's commented on this below the videos, but it was driving me crazy.
Yeah, the ligature.
The equals greater than thing also becomes a magic symbol.
Yep.
I thought,
What is that? That may be. I have nearly turned it off at that point. What
That's
is that?
That's funny. No one has complained about that to me before. That's 100% my like math and Haskell background, right? Like I'm very much used to arcane symbology, and specifically because I was writing a lot of Haskell, I like added that editor extension so that my monadic bind operations looked all fancy, like I'd seen in a math textbook. I felt at home. Sorry.
It's
Yeah,
funny.
it's very stylish. Oh man, I was just looking at think typos, typos, typos. I could see the single character bugs coming down.
Yeah,
So
it
the
hasn't bit me in practice, but
so the Atlanta group that you were part of, I live in Atlanta currently, so I visit the Atlanta users group, the Atlanta Ruby users group whenever I get a chance. Haven't since COVID started, but I've been going for the past few years. Is that the group that you were a part of?
I definitely was a part of that group. That is a great group. This was a little like satellite offshoot thing that we spun up and ran for a little while.
Okay.
I have since lived in DC and now in California and have not done a terribly great job of keeping up with my Atlanta people. So I assume it has probably since fizzled out. But yeah, it was a little like satellite offering of the Atlanta Ruby group.
Cool. Well, so let's go ahead and dive into our topic on refactoring. So, can you give a high level overview to the listeners of what is refactoring and when should we start doing it?
Yeah, sure. So refactoring, I think refactoring like code smells is one of those terms that gets like bandied about, and sometimes people use it sort of loosely and informally, and sometimes people assume a formal definition. When I talk about refactoring, I try to mean a strict change to the way that code is organized in a way that does not change its external behavior, right? Like I don't just mean cleaning up the code and rearranging things. I try to make it a pretty strict, specific thing. So I will say, like, if anyone has not seen like Sandy Metz's talks on, Nothing is Something, I think Sandy like explains a lot of these ideas very well and would highly recommend them. Key idea behind a refactoring, right, is that, your code is complex. It probably has a lot of interdependencies. Any change is risk. And we would like to come up with a set of techniques that we know are safe, that we can apply kind of mechanically and trust that they're going to be stepping us in a positive direction and let us make the changes we want to make in a way that is safe.
Yeah, on that, I loved what you said about only making a refactor when a new requirement comes down the pipeline, and what you talked about in terms of that any change is risk and you could be potentially making things a whole lot worse. I just was curious if you could embellish on that a little bit more. It was just a quick point in one of your talks.
Totally. No, I'm glad you landed on that one. I feel like that's been one of the most significant things for me in trying to practice this a lot. And it's an easy one to miss, right? Like, I think the way that I always approached refactoring before was very much like, okay, I've got this deadline. I've got to get this feature out the door. So I'm going to do it. I'm going to like spike it out, whatever. It's going to be kind of gross and we'll ship it to prod. And then like once it's in prod, if I had enough days left in my sprint, I'd go refactor and clean it up so that it felt nice, right? Like by some arbitrary fuzzy measure of nice. And I think that is just exactly wrong. It's in prod and it's working, right? Like best case scenario, you spend 2 extra days of dev time on something that does not improve the end user's experience and you manage not to break it along the way. You might ship a bug right at the end of things where people thought it was already working, but like maybe more importantly, the change that you're making in refactoring is making a guess about how the feature is going to unfold. And you do not have, like, you will never have less information about the future than you do right this second. Again, like Sandy says that all the time. I'm just parroting this, but it is so true, right? And it always, like, when you approach refactoring that way, it always leads to this tension between your product people and your devs where you go like, oh, I want to, where it often feels like a self-indulgent thing that the devs do, right? Like, I need to go clean it up for my sake. Yes, this has no business value, but like, I'm going to spend some time on it. Is that okay? And it's adversarial. If you flip that around and if you can kind of live with, yeah, I don't love it, but I'm going to wait until I have more information, you like buy some trust with your product people. And what you find is that when the next requirement comes around, you're like, oh yeah, like I'm in this area and I wasn't entirely satisfied with the solution before. Let me take a little bit of time to kind of get that on a good, solid conceptual framework to where this new thing is a totally logical and easy extension of what I currently have in place, right? Like I'm going to take the time to make the change easy now with all the information that I have on hand. And then, your product requirement is a natural follow-on of that, right? Like my refactoring work is a necessary part of delivering to the user, like the value that we both want them to have. I just want to do it in a way that keeps the system kind of clean and tidy for next week's user and next month's user down the road.
Absolutely. I 100% agree because, especially with data and databases too, you don't know where, obviously with experience, you can get some forecasting of where the bottlenecks are going to be. But if you don't know where the bottlenecks are going to, if you don't know if the users are going to use this or this, don't over optimize for the things that they rarely use and rarely has a cost on your system. I love that concept. I think the interesting thing is, like, obviously you want it to be readable and understandable. So there's obviously is a balance in between, being happy with the code, as you called out. Don't just refactor when you're not happy with the code. But obviously you want it to be able to be maintainable in the idea so that when you do get a new requirement and you come back into it, you're not starting from scratch all over again.
Sure. Yeah, and totally. Like, I think that's one of the things that we are trying to focus on in those refactoring workshops is kind of developing our internal heuristics for this just seems better, right? Like, I trust that, like, even though I don't have a concrete requirement for it, I trust that taking this 300 line spaghetti method and packaging up into a couple small objects that have tests around them is just like almost always going to be worth doing. It pays dividends more or less immediately, like even just getting this through code review is going to be simpler because other people can understand it, right? But it becomes a question that you ask of like, is this change worth doing, and is it something I need to do now, and not just a gut feel like I think I should.
So are your workshops more about how do I refactor well, or how do I have good self-discipline in order to know when and when not to refactor?
It's interesting. They sort of evolved over time. I will say, like, we definitely have a devoted few. Like, we have a core group that tends to come to most of them over time. So the conversation has evolved over different offerings. We try to structure them like roughly once a quarter. We change topics. One of the important things for me was that the workshops be a place where we can try to put these techniques into practice on our actual real Procore code base, right? Not some like pared back model, but like all of the warts and everything that you have to deal with getting it into prod. So the specifics of how that play out kind of change based on what area of the app we're working on, right? We had one quarter where we were looking at kind of extracting query objects for some common queries that we were making. And, I think a lot of the early ones were very much about those like tactical, like how do you mechanically do these refactors? How do you spot where they're necessary? Like, how do you kind of follow your nose through making a change? Over time, as they have gone on, and we've kind of, most of the people that come week in, week out, I guess we're doing it every 2 weeks, have internalized those ideas. Now the conversations have moved to a kind of higher level, right? Like, we have this big complicated system. Part of why it's complicated is because we have all of these weird collaborators with like weird interdependencies. So now we're doing more kind of big picture on the whiteboard. Can we do some design about how we'd like this object system to look, and then think about how can we evolve it to that, maybe over the span of months, maybe with different teams working on stuff. One of the interesting questions for me that's really hard to have outside of that specific kind of company context is very often when you're making a platform level change that requires coordinating work across different teams. You're talking about how to manage just that process. That's a conversation we're having a lot these days. I will say, like, the workshops are specifically aimed at refactoring. So sometimes we will indulge ourselves in a refactor that is not immediately motivated by a product need. The workshops meet every 2 weeks, and sometimes that cadence doesn't line up with like a product thing. But in the current one that we're doing, which I'm enjoying a ton, we are working in partnership with another group where kind of the output of the workshops is some sequence diagrams, some designs for like the architecture of the system. And then the squad will go off and like make those changes in a mechanical kind of refactored sort of way. But like we'll implement the designs, and we'll kind of come back and review and repeat. And that's been a ton of fun.
So a mixture of stuff is what it sounds like to me. That's cool.
Yeah, so to kind of recap some of your thoughts that you've said about refactoring, the end result must be the same as the original end result. So that's the idea that you are aiming for, but to make the code cleaner. And I think that's one of the important things to highlight, because a lot of times when I talk about refactoring, sometimes it is almost kind of bundled into the idea of reducing tech debt by changing the output or having a different kind of output. And I think it's important to highlight that distinction, and when you then apply some refactoring skills into whatever the problem is. Because essentially, I've been in situations where I've written a piece of code, I'm not happy with it. I'm like, it's not really the prettiest thing. There's no new changes that need to be made to it, but At the same time, the output's working, we have no end user complaints, and people are happy. But then we get into other situations where we have architected something. It does technically work, but we do see forthcoming problems that's then going to ultimately cause end user issues in the near future, causing us to think, should we really take the time and re-architect this? So we are going to be changing a lot of our database schemas, changing a lot of our associations and how things are working, opening the potential to break things. So can you kind of speak to that between the kind of refactoring that you're referring to and then reducing technical debt and kind of where the line is drawn between the two? Because
Yeah.
there is overlap,
Oh,
obviously.
definitely, right? Like very often paying down technical debt like involves a refactoring, but there absolutely are technical debt pay downs that are bigger changes, like that aren't a strict refactor, right? I think for me, it's really helpful. Like you're going to need to make changes to your system, right? Like it's going to evolve over time. It will need new behavior than what it currently did. I think for me, it's really helpful to separate out though the like this is a deliberate contract breaking change in behavior from this is an incidental reorganization of the code, because the first type are scary, they're risky, right? Like some caller somewhere might throw a runtime error, right? Some user might see something different, and those are changes that should be, you should minimize the blast radius, you should test them more carefully, like whatever you need to do to ensure that that's not a problem. Whereas if you can kind of separate off the strict refactors, those are much safer. And so it's been really helpful, again, like in conversations with my like product and QA people, to be able to draw that distinction and say like, hey, this is a strict refactor, right? There are no changes in user behavior, right? If maybe even though I'm not trying to change anything, I changed a bunch of lines of code, I can sort of say like, oh, we're running a science experiment to kind of prove out that this, like we're going to run it in prod for a week to verify that it did not change behavior anywhere, whatever it is. And it helps to kind of draw that line so that when you do need to make those big changes, right? Like when you need to change the contract about how something behaves, you can focus your time and testing effort on that change and make sure that it didn't introduce a regression. Are you all familiar with science experiments? Is that like a well-trodden, well-practiced technique? It's one that's been really useful for us.
What is that?
Science experiments. So yeah, scientist is a gem out of GitHub. The idea there is it's supposed to help you kind of refactor your critical code paths safely. So you kind of drop in your base science experiment and what you do. So like you have let's say you have a block of code you want to refactor, right? You have some seam, some like method call, and you're thinking to yourself like, I'm intending to refactor the internals of this method. That should not change the behavior, right? For every input, you should get the same output. Dropping in a science experiment lets you actually verify that. So you declare like, here's the block that I'm using. Usually it's your kind of current implementation. And then you can also say like, here's the block that I'd like to try out in comparison of that. That's my like candidate. And so what the experiment will do is in production, it will run both, compare the outputs, and always use the use block. So that's like a strong guarantee that you're not changing the behavior, but you can kind of wire it up to report, if your candidate differs from your control, you can report that however you want. We've got some internal tooling that kind of sits on top of that lets you sort of declare, I'm refactoring this method. Here's the new implementation for it. And if there are any failures, like they get logged, like sent to Sumo Logic and Datadog, and we have nice dashboards to track them. So the strict refactor changes for us are really easy to make. I can push up a new experiment. QA is not going to be concerned about it at all because they understand this idea. And after a week, I can point to like, yeah, we've run it a million times, it never errored. Are we good to cut this over? Cool, let's do it.
So this is the scientist gem.
Yeah. Yep.
So the idea is you kind of got maybe quite a hefty refactor on some critical code, something to do with the billing, and you think, I kind of want to push that in, but I'm not sure. So you actually run both blocks of code in production, the new function, the old function. And the scientist gem says we're going to stick with the old code, but we'll also run the new code over here, and then kind of presumably log to the database or somewhere to see if it does the same thing or not.
Yep, that's exactly the idea. So that's great when you're updating like query patterns, any kind of read-only thing. I like it can't isolate side effects and mutations, so it's only really helpful for read stuff. But there's a lot of power there. You can if you're making something that you think is a performance improvement, often that's really hard to verify kind of in local dev. But the science tooling includes timing, like relative timing for your control and candidate blocks. So you can watch that on a graph and say like, oh yes, that's clearly better. Like let's let's actually use it.
That's very cool. I've never heard of that.
It's really cool. We've been using that to de-risk a lot of our releases to prod. Yeah, and to your point, like I think that's primarily useful on, like you have something that should be a strict refactor, but it's still like it changed a lot of code, and like maybe you made a mistake along the way. One of the things I haven't been entirely satisfied with the refactoring process is that like it is a process, right? Like if you go back and you look through the commit log of a strict refactor, you can see that like I changed one line here, I changed 2 lines here. Like, yes, each one of these is a small step that is safe, but it often doesn't feel reasonable for like reviewers or QAs to understand the work output that way. It still lands to them as a PR with 500 lines of changes sometimes, and it can be hard for me to communicate that the process by which I developed this makes me feel like there is a high level of safety in a way that seems convincing to someone who wasn't there for that process.
I think that when we are developing, let's say Rails applications, it's important to kind of keep this stuff in the back of our head as we are developing. So trying to follow the single responsibility principle as close to the letter as possible, I think will help refactoring down the road. Don't create a class which has 10, 20, 30 different methods that are publicly accessible, unless if it is something like a model. Really keep things smaller, keep things more organized within your code base. And I think that's going to make it a lot easier to refactor if you ever come down the road to that point, because then you're really just talking about, I want to refactor this class. Okay, well, is this class going to be touching anything else, or is it highly dependent on something else? That's then going to change. So if you only have one public method within this class that you're able to then easily test, quote easily, depending on the complexity of it, but you're not going to have to worry about the 10 other public methods within there that could be affecting it. And I think that's where I've painted myself into a corner many times in the past, where I have created a really complicated class that's does something really cool, but then I never touch it again because I'm afraid. Even if I have tests, I'm afraid to touch it because I just don't know how much that's going to potentially break.
For sure. Yeah, no, I'll definitely say that like the way that we started off the refactoring workshops was by trying to look for some candidate places where we could get some wins, right? So we ran a number of like Flay and Flog, the gems that like Code Climate is using for its internal kind of code quality tracking to look for some candidates. And we landed on the scariest thing that was most predominant are these like giant model files or like giant controller files that like clearly have a million responsibilities and are right. They're terrifying to change. And yet we change them all the time because they're at the center of our system.
We're supposed to call them majestic now, majestic methods.
I hadn't heard that. Okay. All right. Yep. Yeah, no. So like, I think probably the most common refactor that we have done has been extracting a class, right? Like trying to winnow down the responsibilities of some incredibly large object by breaking off a chunk of it and like putting in its own class and making that be something that our original object just collaborates with instead of owns.
Yeah, and another pain point that I inherited this problem, but trying to refactor it, it's almost quote impossible, is when you just take in a argument or a parameter like options. You don't really know what's calling this, but all throughout that method and this class, you just see like options and then some parameter or some key off of it if it's a hash. And you're like, I have no idea what's going on here. Like, what else is it expecting? What else is it needing? What needs to get returned? So not doing that kind of stuff is going to save yourself a lot of headaches in the long run. Also using keyword arguments over, just passing in 10 different variables into this method. Then you have some idea or scope or context of what's actually getting passed in.
For sure. Yeah. Like anything that forces you to have to like trace through the whole call stack up and down to figure out like, what is this thing that I have is always going to be a pain to work with. I think that's part of why these extractions to small classes and everything kind of help a lot. Like so small classes are always going to be kind of easier to reuse in other new contexts, but also they increase the code locality, right? Like you can almost always read the whole file and get the whole story. And things like adding keyword arguments or kind of, being a little bit more verbose, but also explicit about the inputs are all things that help you make sure that like the person that's reading this, 20 line method really gets all of what's going on and doesn't have to go kind of trace down other things to understand. I will say one of the hardest parts about refactoring, like one of the hardest refactors for us to make in the Procore code base is changing the name of a method, just because we've got a million lines of code, and finding all of the callers for something, if it's not this like a little bit verbose thing that's unique, is hard. And also, like meta programming and dynamic sending make that even harder. Like it's really, really quite hard for us to be confident that a method is never called, or to know that we've changed all of the callers of a particular method. Yeah. And being a little more explicit like really helps pin that down.
I think metaprogramming is one of the coolest, worst things introduced into programming.
For sure. Like I've loved some of the things I have been able to do with Ruby, but I'm getting to the point where like I want an explicit name for every method. Like I am very loath to call a method into existence that is not greppable in the code base.
I used to be very anti, even with the Rails stuff, which is wonderful, wonderfully done. I used to be very anti Ruby Magic. And what changed it for me was to be able to use it to reduce boilerplate. So I kind of have a load of classes going on where the same thing happens everywhere. And this drives me mad. This is really irritating to me if I've just got to kind of have the same 3 lines at the top of everything. It drives me insane. And I've realized one day that, yes, I can use metaprogramming to kind of compact all that away. And I don't think it suffers from the same problem with the refactoring, because the boilerplate's often something built into the gem, isn't it? So you're not kind of going to be playing hunt the method. But yeah, I'm coming round. I'm coming round to it more. I'm going the other way. I know everyone else is saying less metaprogramming. I'm going more.
No, I think the important thing there, like I definitely will do things like that. Kind of before, what was it? Some version of Ruby introduced structs with keyword arguments. I used to have like a little metaprogramming thing that I do because I got tired of writing attr readers and an initialize method that accepts keyword arguments and sets ibars. So like I would metaprogram that away. And I think that like that can totally be reasonable. The thing that's important is, to me, is everyone who is working on that system needs to understand that that's how that works. Like they need to not be surprised by that, because if something is going wrong and it's in that system, like it's incredibly hard to track down. So you need like a critical mass of people in your org who get that that's why the thing is happening, at least someone feels comfortable reaching out to ask about it. But for those sort of like common core shared conventions, it seems very reasonable to me. Yeah. Like it's a powerful tool that we shouldn't completely discard. Again, you want to be a little judicious about how you use it.
I think that my definition of metaprogramming, or what I would call like real metaprogramming, is when you're having to do define methods, you're taking in a list, an array of something, and then you're defining method names off of that kind of junk, and then having that used and referenced within the application by its full explicit name. I've seen cases where, and I kid you not, someone had loaded data into a database table with some Ruby code, and it would do a class eval on it and then define methods. So if you tried to look through your application code base to find this particular method, you just could not find it. You would actually have to run queries on your database to find what that method is and then update those table records.
That's been like data-driven, Dave. What are you talking about? That sounds perfectly fine to me.
Data-driven development.
That sounds incredibly painful to test.
Yeah.
Well, and not to mention the security implications.
Sure.
I mean, I'm going crazy there, but
well, okay. So before we get too angry, I actually have a real use case of this kind of thing, right? But I definitely have had somebody in a user group a long time ago, come in and be like, yeah, I have this code that people write and dump in the database, and then I have this thing that loads that code, and that's how my project runs. And I thought that was a little crazy. But I have a project where such a similar type of use case happens, right? We have a bunch of rule sets that gets defined by somebody somewhere, right? And we have to store those for various, we call them assessments, right? Like it's testing the rule set. So in the end, I ended up creating a parser to handle this, right? So now I have a very specific, I'm not just evaling Ruby code, which is how we originally made it. We now have a parser to handle it. So it's only, it's a much narrower set of things that you can do, right? But I mean, there are ways to refactor such things, but these use cases totally exist, I guess is what I was trying to get at.
No, totally. And like we do write DSLs, reasonably often. I think there's like there are a couple things that I try to do to stay sane here, and I think like exactly what you're describing makes a lot of sense to me.
And a DSL is a lo-fi version of this. Go ahead.
Yeah, no, like I think the important thing at the end of the day is that the thing that you're storing is not the code to run. The thing that you're storing is some data that you can kind of interpret. Like this is a thing that like doing Haskell drilled into me a lot, right? Like you can represent your program, your rules, whatever it is, as some data. So like whenever we define our DSLs or do anything in this area, I always try to like you have the DSL is just building up some data structure, like some plain value object that doesn't have behavior. And then so like you can load it from the database if you want, whatever. If you have some block that ends up writing some nice human way to express the thing, it doesn't matter where your like AST of your rules came from. Like you have that data, and then you can use that to build an object graph that will do the sort of thing at runtime that you need it to do from that data. I think like having that separation between like the underlying representation, the parsing of it into an object system, and like the actual objects they're doing, it really helps you stay sane. Because you can test those out. Like those are just plain objects. If you wanted to build them in a way that didn't use DSL, fine. Like you can totally do that. If you want to do it in tests, fine. That's very different from like saving some code to eval.
I think this goes back a little bit to what we were saying earlier, right? There's a difference between refactoring a piece of code so that it has the same behavior and sort of refactoring your architecture, right? And this is a thing where you're just like, okay, so maybe you don't like a piece of code, so you refactor the piece of code. But this is a thing where it's like, we don't like this architecture, right? Like this bothers me. So now I'm going to refactor my architecture and change my behavior. I refer to I actually use these particular terms. I always call it refactoring architecture versus refactoring my actual code. Those are just because they're very distinct things to me. And some architecture, some design patterns, right, get you to a place that you don't like. Evaling code out of your database is just a thing that I'm not comfortable with. So I found another way to do it.
Yeah. I think one use case to kind of highlight what you were talking about, John, would be something like WordPress plugins, where you can add a whole new set of functionality that did not before exist within the application through a quote plugin. I don't know what the proper way to implement something like that in Rails, but that would kind of be one of my first thoughts, is to load it into the database and have it evaled. But I think that that kind of feature would take a lot of like architectural discussions and thoughts of like, how do we want to do this and isolate it to where it's not affecting the other bit of code.
Gems and engines, maybe?
No, I'm talking about like your end users. If you have a CMS and they want to add functionality into your application through a plugin that they upload within their own domain, something like that.
Yeah, I mean, that might be an architectural choice that you make, right? Like, I would argue that it doesn't matter how nasty we think the thing is, even dumping code into a database to eval, somebody somewhere is going to think of an actual use case for it. I just might sit here and ridicule the particular use case that you're describing to me. But I mean, reasonably off the top of my head, I don't have a better way at the moment, Dave, for your use case, so I can't make fun of it.
Oh, that wasn't the use case I was referring to when I gave the whole meta programming spiel. They were actually doing this just because I guess they thought it was cool. Maybe they read a blog about like something to absolutely not do in your code base, and they misread the title as like, you have to do this in your code base, because there's no purpose to it, to this level of meta programming.
So I'm going to go out on a limb here, and if you program something because you think it's really cool, I think kudos to you, because that's you learning, right? Unless I have to come in on that project, then I think that's really dumb. Because as long as I don't have to do the work of like actually handling somebody else's experiment, then they're learning from it, and I think that's positive. But I absolutely am going to complain if I'm the person that has to hold a bag of crap at the end of the day.
I definitely I'm a big believer. I have a best friend who's very into like code as art, right? And like it's a wonderful medium where you absolutely can express yourself. but like the art that you do probably shouldn't be in your day job so much. I know it's a quote I've heard somewhere and I can't remember the context, but if you had to use 100%, like code is twice as hard to read as it was to write. So if you had to use 100% of your brain power to write it, like you yourself and your teammates are never going to be able to understand it. Like just write the boring thing.
Well, let's not ignore the important factor of job security.
Totally fair.
Especially in the current times, maybe we should be encouraging developers everywhere to put a few extra meta magical bits in, because firstly, like I said, the obvious job security, and secondly, the lucrative contractor market, and then creating more work for other contractors to come and fix it.
I know that we're saying a lot of things tongue in cheek, but maybe we should outright come and say that we're saying things tongue in cheek, just so everybody knows.
You can say that. I'm
right.
deadly serious.
I'll never come work with you, Luke. Sorry.
You're not the first person to say that. But if you're getting paid by the hour, you may make some money. There's a word you use which is called polysemy.
Yeah, polysemy. It's one of those words I've only ever seen written, so I think it's polysemy, but I absolutely could be wrong on that. If someone wants to correct me, let me know.
Is this going to help my evil plan to further my career by writing progressively more complicated and bad code?
It can be pretty opaque. No, I mentioned that. Can I digress on Haskell for y'all for a while? Like, cut me off if I get ranty.
You bet.
I honestly, so I think a lot about my design philosophy in Ruby is very much informed by my time spent working with Haskell, and it's something I would recommend to any Ruby person. Like, even if you don't think that you're going to use it day to day, it was very eye-opening for me to think very critically about like what does a totally different model of programming look like. And I think a lot of the ideas that I've come to use day in, day out in Ruby kind of germinated there. So like polysemy itself, this kind of relates to like my philosophy on DSL design, right? The idea in Haskell is like there is this separation between pure code, like code that has no side effects. It's just like input in, output out functions like you learned about in math class in high school, versus things that mutate, that change the world somehow. It is a very different thing.
To make it sound so complicated.
I know, right? Like part of it is the mathematicians got there first and slapped a whole bunch of stupid names on stuff 100 years ago. And we're kind of like, there's a body of literature there that we would ignore if we didn't use them. But yeah, like the stuff sounds so much more opaque than it ought to be. I have a real problem with how Haskell is presented to people most of the time. I think it very often comes across as this, like, you have to have a degree in category theory before you can write anything. And I think that's totally wrong, which is easy for me as a person with a degree in category theory to say, but I really do think it's totally wrong. And I think a lot of where tutorials fall over is they start by like, oh yes, like here's currying and monads and partial application. And they really should just like, hey, here's how we program some stuff. Notice any commonalities between the way asynchronous code is handled and the way we do IO? That's because there's like a deep idea underneath it. Like, let's talk about it.
Are you freelancing or moonlighting? Or maybe you've thought about going out on your own. Every week, we have a group of developers at various stages of the freelancing journey on the Freelancer Show to talk about becoming better at freelancing. We also bring in experts to talk about marketing, SEO, and delivering high quality to clients. So if you're interested in going freelance or you are freelance, check it out at freelancershow.com.
How do you do an if in Haskell?
You can just write if. You can absolutely just write if, right? Like you can write some Haskell. Yeah, it does. You can absolutely write Haskell code that looks very imperative. And that's one of the things that I do like about it is like there's a certain domain where writing the sort of like line by line, here are the updates that I'm making thing makes sense. Just like Haskell has what feels to me like just the right amount of friction between the two that sort of like that guides you to doing as much of your code in a pure like state-free, not doing IO thing as you can, but still doesn't make it like too hard to manage the IO stuff when you need to, right? So just because of that small amount of friction, it guides you to really good design patterns. Like when your program starts up, you do all of your like booting up the database and taking user input and reading envars and everything. And the little pieces of your program are all like, oh yeah, this takes a hash. And like, yeah, the hash like represents your environment variables, but like, it's just a hash. So you find that when you need to test that little piece again somewhere, it's easy because it's just, you plug in the inputs. It's the same sort of design you end up with in OO, where like you end up with these small objects that you inject their dependencies as collaborators, and they have like follow single responsibility. It's got one public method. And if you think of that method as call, and you think of injecting the dependencies as like partially applying the function, it's kind of the same idea. Back in math, we learned that if you ever kind of come at the same idea from two directions, there's probably like a fundamental ground truth there that's important, right? Like the fact that algebra and geometry understand polynomials both very well, but both as very different things, means they're kind of like, what's the metaphor? They're like touching different parts of the same elephant, right? And I think there's something like that in like functional programming and OOP. Like they lead you to similar conclusions in a lot of ways. And anytime I arrive at sort of like the same pattern from both sides, it feels like inevitable. It seems like there's something kind of fundamental there. I have totally not answered your question. I am definitely ranting at this point, but right.
Well, and to bring it back to the center a little bit, like all of these things are great that Haskell does. I never felt the initiative to go off and use Haskell because I didn't see it as practical for the path that I was walking. But I think the exciting thing, though, is that you can encounter all these things in JavaScript, even in Ruby, because both of them can do functional programming to some degree. And I know that's where I encountered Curry and Compose and all that in JavaScript land. So if you want something a little bit more practical, we have something immediately at hand.
For sure. Yeah. Like
you probably use every day already.
Yeah, no, that's totally fair, right? Like I think I'd like to believe that a lot of the ideas that sort of like came from Haskell are now becoming more mainstream. I don't know if that's literally true or not, but yeah, like a lot of these concepts are accessible in more, I don't want to say friendly, but friendly languages.
Accessible.
Yeah, accessible for sure.
It's like hobbyists always like to talk about small talk, right? So
yeah,
yeah. The polyglot aspect of knowing multiple languages and multiple design patterns and how one language would think about it, whether it's Go or Rust or Haskell or JavaScript, and pulling that in, I mean, I think that's immensely valuable.
For sure. I think in particular, like the reason that for me, like a Haskell sort of thing is so powerful to learn is that I think there's something to like forcing yourself into programming with constraints that are very alien to you, that really like forces you to look at the whole thing differently, right? Like if you just can't do IO ever, like how do you have to restructure your programming? If you cannot throw an exception, that's just not a concept that you have. Like what do you have to do, right? Like if you do not allow nil to be a thing, how can you still structure programs and stay sane? You're making a face at me like, yes, null is still a thing, but like if you don't allow nil to stand in for anything, like any arbitrary type, like if you enforce a strict separation between the two.
I was nodding my head to agree with you. Like I love the foreign concepts, because then when you encounter them in code or you have a particular problem to solve, Haskell hits on a lot of great things. Functional programming hits on a lot of great things. And if you can draw that, especially in a language like Ruby, that you can do a lot of functional programming and you can use those concepts.
Yeah, for sure. And then like, so if I
best at it. But,
oh no! Like, I feel like I definitely got off on a tangent there, and I would like to answer your question about polysemi because I think it does connect. Like, so yeah, like I said in Haskell, right? Like, you are generally not allowed to throw an error, right? If you have a pure function, it has to return an output. So like, erroring is not a thing that you are allowed to do. Like there are thrown IO errors, right? If the network fails, it's kind of unavoidable. But generally speaking, the way that you handle that, and to your question about like if statements, the way that you handle that is not like there's a conditional wherein if I return nil, I do a thing, and if I don't, I return a thing, or like there's not a conditional like if I caught an error, I do one thing. What you do is your return values are these richer types that kind of model that in, right? So you might return a type that represents maybe I have the thing, maybe I have a nil like value. You might have a type that represents maybe I got an error, maybe I didn't. And those all kind of give you ways to model functions with side effects, right? Like that like maybe it's an error, maybe it's not, is kind of the Haskell equivalent for throwing an error.
All right, but what is the polysemi?
So yes, so the thing you kind of get to in Haskell is like you do want to have all of these side effects, right? If you're writing a real program, like you want to talk to the database, you want to talk to Redis, you want to be able to throw and catch errors when when some very low level thing fails to find a file, you want to handle it way up the stack, and you don't want to have to thread that through everything manually. That's a huge pain. So what you want is you still want all of those nice things about functional programming where you're still dealing with functions that have just like inputs to outputs that you can kind of test in isolation. What you end up doing is you end up defining like, here are all of the effects that my program has, right? It has the capability of talking to the database. It has the capability of talking to the network. And you define them as this like abstract effect type. And so polysemi is a library for taking your abstract defined effect type and being able to like on the fly, to define different interpretations for what that means. So kind of concretely, right, at runtime, when I'm querying for my users, I want to talk to the users table in the database. but maybe in a particular test, I want to reinterpret that effect as meaning look them up in this hash that's in memory, right? Like at runtime, I want my logs to go to actual standard out. For the context of some particular test, maybe I just don't care about logging, and so my logging effect is just a no op. It is a like very math speak way of doing that, but again, like this is like that's so core to us as object-oriented programmers, right? Like we tend to have like some singleton logger thing that we reach out to, and in test environments we like swap it out for some different implementation. It is the same idea. It's just a like, how do we get that nicety in Haskell ecosystem that requires all this like mathematical formalism, or else it won't type check.
So to bring this down or bring this back to where we are a little bit, because this is a huge rabbit hole that I personally love discussing functional style, OOP style, and like the benefits and just anyway. So you use Ruby today, am I correct?
Yep. Day in, day out, for sure.
So my thought. So maybe to wrap this up, like, do you like how the mixture of OOP and functional style that you get in Ruby? Are you okay with it, or are you gonna bail on us and run to Haskell tomorrow?
No, I'm definitely not gonna bail. No, like I again, kind of a lot of my problem with how Haskell is presented is oftentimes people will pick the sort of incidental things, the monads and the tail call optimizations, and try to just port over like, how do we do this in Ruby, and not kind of think too much about like, do we need to do this in Ruby? Like, is this a thing that even makes sense? Different tools are appropriate for different problems, right? Like there's a ton of things that Ruby's good at. Like I absolutely, like my biggest pain point working day to day in Haskell is I don't have try, right? Like Ruby code at runtime is very similar to the Ruby code that I as a human wrote. And that is a huge power. Like I can poke at a living system and like ask it questions about how it works in a way that just like doesn't make sense in the Haskell world. And right. And for exploratory things, for like metaprogramming sorts of things, like that's amazing. So absolutely like not going to bail on Haskell. That said, I do also greatly enjoy working in Haskell, right? Like I think there are some projects that are coming at work where it's like the right fit for the job, and I'll use it when it makes sense. I think like the thing that I really like want to encourage people is to take the time to expose yourself to these different ideas. Like circling back, a lot of why I really enjoy this like methodical refactoring approach to programming is it helps me recapture in Ruby a feeling that I got working in Haskell a lot, right? Like in the Haskell world, you have these really like hard, deep, like very abstract problems. And you like, sometimes you'll have to sit and think very carefully about it. And you have to like really work at the solution, and you write down your solution. But then like, once you do that, the compiler goes like, oh, hey, I've got a lot of kind of mindless work for you. Like these 3 lines don't make sense. Can you tell me what you mean to do here if something's nil? And I'll kind of step you through it. So there's this skew of complexity where like, sometimes you have to think really hard and deeply, and that's satisfying, but I can't do it all the time. And sometimes you get to kind of like, be pretty mechanical and just do these little like 5-minute tasks and check them off and knock them out. And like, I find that really enjoyable. And doing this sort of strict refactoring style captures a lot of that same feeling in the Ruby land, right? Like I have to think carefully about my design, but then there's these pretty mechanical steps that I take.
You're converting your constraints into sort of self-discipline in Ruby.
Yeah, totally. Right. And like, I'm very glad for that Haskell experience to inform the way that I write Ruby, but like Ruby's great for a lot of things. And I'm not planning on abandoning it at all. It's just like my interactions with it are deeper for having that extra perspective.
Totally get it. Right. Like, so my perspective is Ruby will let you hang yourself, right? Like it just
Yes.
does.
Yes.
You can do anything. Like we talked about metaprogramming earlier, and I was hoping to bring this up because I personally also happen to agree with like the sort of like when Ruby, refactoring is more about self-discipline and about choosing your own constraints than anything else. Well, I want my code to look this way, but it doesn't have to. You can write imperative code in Ruby. I'm pretty sure you could get pretty close to purely functional. There are a number of people making it happen. In Ruby, you can get pure OOP, but we don't. We mix it all together. And we say, I like OOP over here, you're good. I like functional over here, you're good. So anyway, awesome. Anything else we wanted to discuss today?
Can we have story time?
Sure.
Are you telling the stories, Papa Luke, or are you trying to get somebody
no one
else
wants
to
hear my stories. So I understand that James, I failed my PhD. Some people don't complete their PhDs, whereas I failed mine. I don't like to kind of complete it. I often tell people I have the wrong half of my PhD, the first half rather than the second half. Like James, I wanted to be an academic and a mathematician, not a topologist. It's disgusting, but a real mathematician
Rude.
that uses numbers. But I understand. I understand there is a story concerning your PhD, which I would like to hear.
Yeah, so like this is sort of my transition out of academia and into coding stuff. Like I said, I intend to be an academic mathematician. I was studying kind of set theoretic topology, foundational stuff, abstract nonsense. I'm a huge fan of abstract nonsense. But yeah, so there was a lot going on in my life at the time at which I sort of bailed on the degree. But definitely one of the contributing factors was I found that the questions that I was asking, like exploring for my thesis, I could answer, but the answer was, we can't answer this, if that makes any sense. Can I digress mathematical for you for a second?
How can something, this is math, surely this is perfectly concrete
right.
and sensible.
No. Yes, exactly. Right. Like that's so much of why I wanted to get into math in the first place, is it feels like it's the sort of like, yeah, so we're going to prove something and then we'll have it proven. And as time goes on, we'll eventually figure everything out. And isn't that nice? But no, like so much of 20th century mathematics is no, that's not how it works. Yeah. So it kind of boils down to like this statement is false sorts of contradictions that are baked into the foundation of the math. But it turns out like there are statements, usually they're statements about like infinite sets. Like you can ask questions like, are the rational numbers, like is the set of rational numbers as big as the set of real numbers, and is there kind of something in between? Like you can make that question precise. And in the 20th century, we proved like the statement, there is nothing in between the two, cannot be proven. You can prove that statement can't be proven. You can also prove that the statement cannot be disproven. So you are left with a resounding shrug, right? Like, I don't know, some mathematicians work in models wherein they choose to accept that is true, and that's fine. No one can tell them that they're wrong. Some mathematicians work in models that it's not true, and that's fine. No one can tell them that they're wrong. Some people kind of give up on the whole thing, and that's kind of what I did. Ultimately, I found it very dissatisfying, right? Like at some point, like how can this ever matter? Like it's a really fun formal game, right? But it ultimately felt a little inconsequential. So fast forward, I ended up giving this talk at a bar back in DC. We have like nerd night things. I'd say it's a pretty common national thing. I had been going to nerd nights for a while and volunteered to give my rant about how everything is broken and we can't ever know things. At a bar, and it just so happened that my mom was in town for that weekend, so she came, and I made an allusion to the fact that she was in the audience, and I was sorry for not finishing the PhD. So I will say, like, I view that as my dissertation defense, and one of my proudest moments was that, like, my review panel, like the audience that were there, all like went and talked to my mom later, and so I got off stage, and there was this lady just like drunkenly accosting my mom, saying like, "He's fine. He can do whatever he wants. He doesn't have to finish the PhD." And my mom just being there like, "Yeah, I know. I was great. She was very supportive." But that was a fun little cap off to my math experience. I'm enjoying the programming I'm doing. I get to tickle a lot of the same itches.
Have you found the certainty you crave in the world of Ruby, that notoriously black and white, strongly typed language?
That's fair. Like, it does feel more concrete, right? Like there's a way in which like programming lets you wrestle with all the same abstractions and ask, like, exercise all of the same problem solving muscles, but it helps you build a thing that feels a little bit more real. Like, I know you can't hold the software in your hand, but like you are building a thing. Like there's a craftsmanship to it that I've always found really appealing. So yeah, no, I still don't feel as grounded as I need to, hence the constant running of science experiments and whatnot. But it's better. It's better.
I blame Bertrand Russell.
Yes, me too.
Blasted Brits.
Well, hey, I'm going to get us over to picks. That's all right. Is there anything else you wanted to talk about?
Nope,
Good?
that sounds great.
Well, James, if people want to follow you online and see what you're up to, where should they go?
Not terribly great at being social, but you can definitely follow me on Twitter. I almost never tweet, but feel free to shoot me a message. That's probably the easiest way to get in touch. I have a blog. It hasn't been updated in years, although this experience might spur me to action.
And what's your Twitter handle?
Yeah, James Dabbs. I am James Dabbs on most places.
Have you thought about learning to do native iOS development? Are you using Swift at work? Or maybe you've considered writing applications for macOS. We have a podcast that covers all of that called iFreaks. We have a new panel and a lot of exciting things to talk about, so come check us out at ifreakshow.com.
Let's do some picks. John, do you want to start us off?
Yeah, in the spirit of our topic today, I went and dug out I went and dug out a couple of my old links that I just keep these favorited in my browser. And it's just sort of my refactoring reference whenever I'm just like, something's wrong here. I don't really know what's wrong, but something's wrong. And I'm just like digging through trying to figure it out. So I'll put a couple of them in. But more or less, these are just like, one of them is basically techniques for refactoring. and the other is kind of like a list of smells, and so I'll put those in or whatever. But they're both like super useful because I don't know. I remember a lot of stuff, but I don't remember all of it. So sometimes I'm just like, I don't know. I smell something, but I don't know what it is. So just throwing those in there. That's what I have for this week.
All right. And Luke, do you have any picks?
I was gonna, since we've got the mathematicians here and we're doing the real computer science, I was gonna pick the annotated Turing, but I think someone picked that recently. It might have been me before. If you don't know the annotated Turing, it's a book of Alan Turing's original papers in the 1930s, and it's good stuff. But instead of that, I'm going to pick an interview with a fantasy book author who you may or may not know, R.A. Salvatore. I grew up reading his books on dragons and things. And of course, way back then, we didn't have the internet, so I didn't know anything about him. I just knew he read good books. And he has interviews on YouTube now because YouTube's a thing. And there's a brilliant 50-minute talk he gives about the history of books, the writing process. He really drills into stuff. It's from 2010, so it's quite old now. And it's before a big project of his had some trouble. I had a big scandal about it in the East Coast area. But I highly recommend, if you've read any of his books or you're into fantasy, this talk by R.A. Salvatore, which I'll leave a link to. It really is very interesting.
Cool. And Matt, do you have any picks?
Yeah, I'll break my tradition of only having one. This time I have two. One product I've really been enjoying has been Figma. I'm not a designer. I suck at design, but sometimes I need to get an idea out, and Figma has been the easiest to get my ideas out of my developer brain. Shout out to that. And then in the spirit of this talk, I went back and found the guide that I had used on functional programming in JavaScript. And I don't know if you've seen it, James, but it's the mostly adequate guide to functional programming. And they broach all these wonderful subjects, which I was hoping we would talk more about monads and IO and fun stuff like that, because that's where my brain starts to break. But I find that there is lots of wonderful things to steal from this in your everyday life.
That's awesome. No, I haven't seen that one. I will say, like, I am happy to talk monads with anyone that wants to talk monads. I just find that if you like ambush people with them, they usually resent that. So yeah, I would like to encourage you that there is value there, but don't feel like it's the first thing that you need to know.
Yeah, I like to see things from start to finish, and once you get to that section or IO or any errors, then that seems like a much bigger, deeper, paradigm breaking subject that you need to really spend some time wrapping your head around.
I'll jump in with a couple of picks. My first pick is a hammer drill. So I recently had to drill into some brick, and the cordless drill that I had just was not doing the job. Hammer drills are amazing. So they are essentially, you have a cordless drill, and it's like having a hammer right behind it and pounding that drill as it's going in, but doing it 100 times a second. So hammer drills have a purpose, and they are awesome.
+1 for that. And
second,
once you get, you won't go back.
Yeah. So they are really, really helpful. My second pick is a recent episode that I did on Drift and Ruby. It's one that I really enjoyed doing, and it was a lot of fun. And it's video chat with WebRTC. And essentially, from start to finish, not using any library, or rather no external services, we built a live chat application, a live video chat application. So it was a really fun episode. It actually took me quite a while to prepare just because my JavaScript's not very, very strong, but just the whole idea of working with WebRTC is not a trivial thing. It was a fun episode. James, do you have any picks?
Yeah, I've got two. I'll +1 the refactoring guides. Those are definitely like references that I use. I guess my two picks are, I want to recommend Learn You a Haskell for Great Good. It is the closest thing that the Haskell language has to Wise Poignant Guide. So if you're looking for an intro, place to get started, that's definitely a nice one. The thing that I have been like recently made aware of and very interested to follow more is the Unison programming language. It's a like Haskell-ish language written in Haskell, and that's not the reason that I care about it. The idea there that's really interesting to me is it's content addressable. Like a function is defined or is identified by a hash of its body. And so it's this big exploration of like, what does programming look like starting on that foundation? And there's these really interesting things that fall out. Like renaming is trivial because a name is just like a get branch pointer, right? Unit tests just have to run once, ever. And I mean ever, because like a function kind of pins all its dependencies where like, you know that none of the things that you ever call down the stack have ever changed. So what's the point of rerunning the test? It's an append only language. So I think that's my next exploration into like what's a wildly different programming paradigm and what can we learn from it? Unison name the language.
Awesome.
That sounds pretty far out.
Yeah, it's wild. I don't know if it's academic wonkery or anything useful yet, but it's intriguing.
All right, James. Well, it's been fun talking with you, and we will chat with y'all later.
Yeah, thanks for having me on.
Thanks for coming. Take care.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.